when they exist in a testing framework. So we can change what we expect the software outcome to be without having to wade through a big specs document to find the right page with the right piece of wording and change the to and, for example. Not that you could do a sentence that changes the to and to make sense, but anyway, you get the meaning anyway. So how many people have seen a specs document that looks like that? Yeah, you'll come across them quite often when you work on software projects. I've had a number of these dumped on my desk. I've read not a single one of them. Okay, I always go and ask questions and get people to write down in quantifiable tests how they actually want things to perform. So just to dispel a myth, within TDD, testing is not about finding bugs. Okay, we're not concerned with how many bugs are in our system when we're talking about testing within TDD. The tests we write for TDD process are only there to say whether we're doing what the customer expects us to do within certain defined parameter constraints. Okay? You can't possibly write tests for every single case under the sun. That's where proper software testing with proper software testers comes involved, and also a good pragmatic idea of when you're done. Testing is, however, about communication. So it's a communication between the people who want a piece of software on your left and the people who are delivering the software on the right, and a way to allow them to communicate to each other in ways that both of them can understand what has to be done and what's going on. Does that make sense? Did that sentence just make sense?
No, that's good.
Okay, cool. So people can quickly add to tests. If you've done them in the right frameworks, they can quickly create another scenario and ask, hey, what does this software do under this scenario? They can actually say, hey, this is what it should do, and find out if it's actually doing that. And the great thing is that these can be passed up the line, so they're not just the domain of people who are just writing code all the time. They can be passed up to people who actually make the decisions about software. So unlike your thesis or anything else you might have done in university where you get to make a lot of the decisions, software world doesn't necessarily work that way. There's usually a big boss guy or woman who decides that actually that's the software that they want, and what you've delivered actually doesn't do what they want. Despite the fact that you've got it in plain text in English, this is the specification, you turn up and you deliver something that's actually completely devoid of what they were actually expecting. So that's where testing comes in. They can actually start writing down, if you do this, and then I do this, this is what I expect. Does that make sense? Cool. Let's just make sure. Yeah, and also they stay around. So you're not just going to, with a spec document, you have to go back and read what your previous specs are. If you've been around in software for a number of years and your software project is growing and growing and growing, how many people are actually going to go back and read spec documents from 4 years ago to find out if they've broken something that was in the spec 4 years ago that's been working for 3 years, but they might have broken just now? Not very many people are going to do that, okay? Whereas if you've got automated tests that are running regularly, running against your project that tells you that your specifications are working, then you can actually have a certain degree of confidence, not a complete degree of confidence, but a certain degree of confidence that you haven't broken them. So, testing is all about, it's all about defining roles within software, defining your test in terms of that role, and then working out what the expected outcomes are if you proceed down a particular path. That's all a test says. The test says, given that this is set up in this context, so say I'm a user of a Snapper card, and I've got $10 on my Snapper card, so that's my context, that's what I'm setting myself up as. If I get on a bus and I try to do a trip that costs $11, then something bad should happen. Maybe the snapping machine should explode. Maybe not, perhaps not. But we've all got to trust each other that we all know what's going on and we all know what the right outcome is. So obviously, as a developer, I might make the snapping machine blow up, but as a BA, I didn't actually want that to happen. So my expectation wouldn't have been the snapper machine blowing up. It would have been a big red light saying, actually, you can't pay the fare. Okay? Does that make sense at all? Okay. So this is a bit of a ramble, so if you've got any interjection, you're more than welcome to interject. So it's all about teamwork, okay? One of you is going to be pulling the other one through. So it might be the BA who has an idea of how the system really should work, helping the developers design the right system. It might be the customer actually communicating with the BAs as to exactly what they want out of the system, so that the BA can write the specs and write the tests. And it's all about us working together. So what I'm going to give you is a kind of a little framework of an acceptance test. So we call these tests acceptance tests. From this high level, we call them acceptance tests. You'll go on and you'll learn about unit tests, which are, or you might already know about unit tests. How many people know what unit tests are? I think they know what unit tests are. Okay, cool. All right, preaching to the converted. So acceptance tests are from a much, much higher level. They're about the acceptance of the system, essentially, not essentially saying that the code that you're writing is doing the right thing. They're about writing from a much higher level, generally from the experiences of a customer. Okay? So we write to a standard format, and that just allows us all to communicate with the same language. So we're trying to get down to this common language, which is our tests. And we start with a protagonist, so the person who's actually carrying out the test. So you've got to ask yourself, who am I writing this feature for? What's the benefit that it will bring? And that will give you the protagonist that you want to write an acceptance test in the guise of. Then you want to put yourself in their shoes. And then we use what's called the GWT syntax. Okay? And it is a syntax, it's runnable, it can be pushed into different frameworks. And we use it's called GWT because it stands for given, when, then. Okay? And it's a very commonly accepted syntax for writing acceptance tests. It's a great way to get into writing the tests and actually everybody understanding. So they're all written in the first person. That's one of the first rules. So you never do it as somebody else from outside. You always become that person and understand what they want to get out of a test. So the given is you do it as somebody with a certain setup. So in the Snapper example, given that I am a Snapper customer with so much on my card. Does that make sense? That's my given. When is the meat of the test. So when I get on the bus and try to pay a fare that's greater than $10. Yeah? Then the then part of the test is the criteria. So this is how you know whether the test is passed or failed. Then the Snapper machine should blow up or flash a red light. Okay? Kind of sinking in, making sense? Okay, so G stands for?
Given.
Yeah, W stands for? T stands for?
Yeah.
Awesome. Okay, cool. Okay, so another example test. So say I've got a checking account. Since the money must come from an accounting place. Given a checking account with $50 and a payee named Acme, and an Acme bill for $37. So you can have as many lines as you like on the given idea. You can actually start writing lots of different things to set up your context. Generally, they should be short and succinct and tell a story. When I do something, in this case I'm paying my Acme bill, then something should happen. So then I should have $13 remaining in my checking account, and the payment of $37 to Acme should be listed in recent payments. Does that make sense to everybody? Anybody here a banker? No. Oh, well, okay. Does that still make sense to everybody? Okay, so it's English language, it's easy to read, it's succinct. So if I have $14 in my checking account at the end of this, is that a pass or a fail? Yeah. Thanks, fail, yeah. $14 is more than $13. Anybody here good at maths? So you can see that we're writing in a very succinct language that should be communicative to anybody within the team. Now here it's a very convoluted example. Everybody should be able to understand that. You don't need any kind of insight into how banking systems work. It's not to say that there won't be any technical language within these tests. Okay? When you're writing tests, don't shy away from technical language that everybody understands, but be sure to make sure that everybody understands it. Okay, so if you pass it up the line or down the line, by up the line I mean towards your customer, by down the line I mean towards the developers, then as long as everybody understands it within the team, then it's still all right. So this framework syntax does kind of have a name. It's called the Gherkin syntax. Okay, And you'll come across Gherkin syntax if you ever work within Ruby, within a behavior